In our last video, we were introduced to the sine, cos, and area rules. Remember that in any triangle, the vertices, the corners, are named with capital letters, and then if you follow across from those vertices, you can name the sides with lowercase letters. And so the sine rule, definitely the most straightforward of the rules. You just need any combination of two fractions. So you can put side over sine of the angle equal to another side over side of that angle. Okay? Or if you're working out an angle, then I actually encourage you to switch this around and put sine of the angle over the side equals to sine of the angle over the side. Okay, always good to put the unknown on top. If we don't have a nice pair like that, where it works out like there's a side opposite an angle, and that doesn't work, but instead we have two sides and an included angle, that's when we switch and we use rather the cos rule. Okay, we follow the same process, and so we'll substitute in the lengths of all the sides that we do have, and we just need to have that one angle there. So in this format of this equation, A is the given angle, and then we'd have the two sides on either side there, the two adjacent sides. Okay, one thing that is just a helpful reminder is in maths, pluses and minuses separate terms. So that whole 2bc times cos A actually becomes one term. So just be careful when you're working questions out with that. And then finally, the area rule, a half AB times sine C. So again, depends which angle you have. If you were given sine A, then you would switch that out and you would say a half BC. So it's very good to practice as many of these questions as possible so that you get good at knowing how to adapt the formula. Please don't forget though, because this is something that a lot of my students forget. If you have a triangle that is a 90-degree angle triangle, it's not necessary to overcomplicate any solving of this triangle. A 90-degree angle triangle goes back to the fact that sine is equal to opposite over hypotenuse, cos is equal to adjacent over hypotenuse, and tan is equal to opposite over adjacent. Okay, so have a look first before you jump to anything on the formula sheet and say, is this a right angle triangle or is this a triangle that has no 90 degrees? And that is going to be how you address the question. In our last video, we solved triangles, so we used the sine, cos, and area rule. In this video, let's see if we can complicate that a bit, because they like to ask us questions like this, where there's actually more than one triangle that we could work in, and we really need to keep our wits about us. So it says here, given quadrilateral ABCD below, determine the following: the length of AC, then the length of AD, and finally the area of ABCD. All right, so we've got quite a bit of working out to do. Let's have a look first of all, the length of AC. So our trigonometry applies to triangles. So they have said to me in the question here, and it's a little bit misleading, but they have actually spoken about a quadrilateral, which this is, but I am better off actually just breaking this up into two triangles to see what I have to work with. Okay, so now if you look here at the length of AC, that actually belongs to the yellow triangle and to the blue triangle. So I've got options there. So what I then do is I say, okay, well, which of these triangles has more information? So in the yellow triangle, I've got two angles and a side. And in the blue triangle, I have one angle and one side. So I definitely have a little bit more info in that top triangle. And now I check, do I have any 90-degree angles? And I don't. And so that means that I'm going to jump to either using the sine or the cos rule. Okay? The area rule I only go to when the question specifies something about area. So let's try and see if we have enough information to make the sine rule work here. So I want this length here, AC. We could actually call that B because it's opposite angle B. And then I need another pair. Okay, so I've got a side length and an angle. So the sine rule is going to work here. And so that's going to be my strategy here for answering question A. Okay, now I ask myself, what is unknown? And in this instance, it's a side length. So I want to put that in the top of my fraction so that I can solve it. So AC over the sine of the angle opposite that, 110 degrees, is equal to BC, which is 91, over the sine of the angle that's opposite that, which is 31 degrees. Okay, and then we can move that sine 110 across, so we can just solve for AC. So it's 91 times by sine 110 over the sine of 31 degrees. Okay, check that your calculator is in degree mode. You don't want to do any weird things there. And so we're going to add a fraction, 91 times sine of 110 over sine of 31. Gives me an answer there of 166,03, and the units there that they're working in is meters. Okay, so now what I want to do then is I want to write that in here just so that I have the measurement to work with, because generally these questions build on each other. Okay, so now that's A. Question B says the length of AD. All right, so what do they want? They want this side here, the length of AD. Okay, that is only in this blue triangle. So now I look and I say, all right, what angles am I dealing with? I've got an angle across from the side I want, so possibly the sine rule here, but then I need another angle across from a side that I have, and unfortunately I don't have enough. So now I say, okay, well, let's check that the cos rule will work. And that means I need to have an angle that is included between two known sides. Now I was given this side and I've worked out that side. So this is definitely going to work out for me. And so I'm going to jump to using the cos rule here. All right, so the cos rule, what I do is I take the unknown side and I put it on its own on the one side of my equation. So that's going to be AD squared is equal to, and now I'm going to put the two sides that are adjacent to that angle there. Okay, so those are going to get squared. 166,03 squared plus 235 squared minus 2, this is just the formula now that I'm applying, times 166,03 times 235 times by the cos of that angle there that they've given me, which is cos of 49. Okay, so AD squared equals. And now this is lucky because actually I can just type this all in. Okay, it's always when the angle is missing that we actually have to work quite hard at solving these things. Okay, so I type all of that into my calculator and I get an answer here of 3159,98503. Okay, I'm not at the final answer because they asked me to solve for AD, not AD squared. And so that's why I'm writing all of these decimal places, because I don't want to lose anything. I don't want to round off and then affect the accuracy of my answer. So now what I'm going to do to end up with an answer that's not squared is I'm going to square root both sides. So I'm going to now square root this answer, and that gives me an answer there of 177. This is my final answer, so I can round off to 2 decimal places. So 0.75 meters. There's the length of that side. Okay, and then finally, they are asking me for the area of ABCD. Now, just looking at the few sides that I have here, it's not any kind of special quadrilateral. So I think, again, instead of us trying to say, well, is this length times breadth, or is this maybe a parallelogram, or let's rather just keep it in the two triangles, because trigonometry is helping us to work out the triangles. So let's work out the area of this yellow triangle and the area of the blue triangle, and then we simply add them together. So the area rule says that we want a half of AB sine of C. Okay, so again, we need an included angle, which is a small problem here because I've got this angle and this angle, but I don't have the length of AB. So I'm going to have to see if I can work out this angle C. Okay, and that just takes me back to my grade 8 geometry. Okay, so what we can say is that angle C plus 110 degrees plus 31 degrees is equal to 180. And because this is an exam paper 2 question, we actually have to give a reason. So interior angles of a triangle. Okay, and then we can just work it out. So what is 180 minus 110 minus 31? And that gives us an answer there of 39 degrees. Okay, so now I'm ready in my yellow triangle. Let's see if we can color code this. So area of triangle ABC is equal to a half times 91 times that 166,03 times by the sine of 39 degrees. So let's type that into our calculator, see what we get. Okay, that gives us 4,754,1159. Remember, it's not a final answer. We can't round off. Now we want the area of the blue triangle. So area of triangle ACD, and it's a half. We just want 2 sides and an included angle to help us work this out. So a half times 166,03 times 235 times by the sine of 49 this time. Punch that into the calculator. It gives us a huge answer there. And now we can finally say, all right, well, we're ready to answer question C. Therefore, the area of the quadrilateral ABCD is equal to, and we're just going to add these two things together. So plus the answer that we got earlier, and that gives us a huge 19,477,39 meters squared. There we have the area of the quadrilateral. Let's look at one of these examples that always seems to stress everyone out. So consider the figure alongside and determine the length of AC in terms of P, Q, and H. So my students say to me, ma'am, there are no numbers here. I don't know what to do. Okay, let's just try and stay calm. P, H, and Q, those are perfectly acceptable variables that we actually do know how to work with. So the question here says, determine the length of AC. So we're going to do, in a very similar fashion, we're going to just say, okay, well, what kind of triangles am I working with? So I've got a triangle here, and I've got another triangle, a right-angled triangle. Try not to miss that. Down here, okay? They want the length of AC. So my first instinct would be, can I work it out in this right-angle triangle? Because that's definitely the most straightforward. But they want it in terms of P, Q, and H. And P, Q, and H are all up here in the blue triangle and not in this turquoise-ish green triangle. Okay, so if I'm determining a length, I'm going to try either the sine or the cos rule. Now, technically, I have this angle and I have this angle. Okay, I want this side here across from D. Okay, and the good news is it is opposite an angle that I want. Okay, the less good news is that the other side that I'm given is not opposite a known angle. But in any triangle, I can actually work out the third angle. Okay, so without freaking out, we're just quickly going to work out the size there of angle A. So angle A is part of a triangle, so a triangle adds up to 180 minus P minus Q. Okay, so that is essentially the answer of that, and this is the interior angles of a triangle. Okay, now my advice to you would be not to leave it at this point. Don't leave minus P minus Q, because if you can think back to the cast rule, it was 180 minus something. So let's take out a negative if we factorize it. So 180 minus, okay, and the more of these you practice, the more second nature this becomes, minus P plus Q, because that's going to help me later on. I'm going to be able to actually reduce something that looks as complicated as this. Okay, so let's tackle question A now. So they say we want AC over the sine of P is equal to, and now we want DC, that's H, over the sine of this angle that I've just worked out, 180 minus P plus Q. Okay, let's times both sides by sine of P, sine P, and now we are left with AC is equal to H times sine P over the sine of 180 minus. So going back to our knowledge of the cast rule, C-A-S-T, okay, in the 180 minus quadrant here, sine is positive. So this can reduce. I don't have to write that 180 anymore. I can reduce it and say, well, this is sine of P plus Q. Okay, and if I didn't do that factorizing, I wouldn't have been able to see that. All right, so look at what's happening. The next question is asking me something else, which I haven't even read yet, but I'm really feeling excited because I've got an H, a sine P, and a sine P plus Q in the denominator. So that is definitely looking promising. Okay, and now it says, hence, show that AB is equal to this whole thing. So AB is now a new thing that I want to find out, okay? And AB is part of the right-angled triangle, okay? It is also referring here to the cos of angle Q. So I've got one small problem because angle Q is in the blue triangle and not in this greenish turquoise triangle, okay? But they did tell me I have two 90-degree angles here. And so that makes me think, and again, the more you practice, the better you become at spotting these things. That makes me think that these two lines have to be parallel, okay? And so what does that mean? That means that angle A is also equal to Q, okay? So angle A, or maybe we should put its sides in there. Angle BAC, just so we know what we're talking about, is equal to Q, okay? And that's because of alternate angles, and AB is parallel to CD, okay? And what we should actually do is write the whole proof. So because these co-interior angles are equal, therefore these lines are parallel. But for the sake of time, we're just going to jump straight to the fact that that is Q. Okay, now with regards to Q, grade 11s, let's identify our opposite and our adjacent and our hypotenuse, okay? The hypotenuse is this AC that we worked out earlier. And then we are given, or what do we want? We want AB, which is here next to this angle. This is the adjacent side. So A over H is equal to cos. Cos theta, or cos Q in this instance, is equal to A over H. So now let's write that down. Okay, we want A, so AB equals AB, side I want, over the side I have, AC, which is this whole thing here. Ooh, let's write it as AC for now, is equal to the cos of Q. And then what we want to do is we want to times both sides by AC so that we get rid of that denominator. So times AC times AC. So now we have AB is equal to cos of Q times by this whole fraction here for AC. And what you'll see is if you times cos Q over 1 by this, you end up with the answer. And so I'm just going to jump straight there. I'm going to be guided by what they've asked me. So therefore AB is equal to H sine P cos Q over sine P plus Q. And there you have it. These ones, they require a bit of practice, but you still treat them the same. You still start by trying the sine rule, then you move on to the cos rule. Only do the area rule if they specify something about area. And if you have a 90 degree, go back to SOHCAHTOA.